Hello friends, I'm Bob. In this video, I will be showing you the solution to the Maclaurin series of tangent inverse x using the formula shown in the top right hand corner of this video. But before I do so, if you guys like this video, help me press the thumbs up icon below this video. Basically, we are going to express the Maclaurin series of tangent inverse x up to and including the x to the power 4 terms. And using the following formula shown in the top right hand corner of this video. The formula shown in the top right hand corner of this video tells us that a function can be expressed as an infinite series in which my f0 is the function evaluating x equals to 0, f prime 0 is the function differentiated once and evaluating at x equals to 0. We have f double prime 0 is the function differentiated twice and evaluating at x equals to 0. F triple prime 0 is the function differentiated 3 times and evaluating at x equals to 0. And f4 times prime 0 is the function differentiated 4 times and evaluating at x equals to 0. We will start off solving the problem by letting my function of x be equals to tangent inverse x. Then we find what is my f prime x differentiating tangent inverse x one time, and we will get the following: 1 over 1 plus x squared. Then we next find what is my f double prime x. We will use the quotient rule of differentiation to find my f double prime x. So my denominator will be 1 plus x squared, the whole thing squared. And then we have the numerator as follows: 1 plus x squared times 0, subtracting away 1, and then we differentiate 1 plus x squared, we get 2x. Now we simplify the whole equation and then we get the following, which is basically just negative 2x over 1 plus x squared, the whole thing squared. Then we evaluate what is my f triple prime x differentiating f double prime x one more time. Same thing, we're going to apply the quotient rule of differentiation and we get the following. In my denominator, it would be 1 plus x squared to the power of 4. And then we have 1 plus x squared and differentiating 2x, we will get 2. My negative sign will be out of the fraction, and then subtracting away 2x, differentiating 1 plus x squared, the whole thing squared, we get the following, which is 2. 1 plus x squared, differentiating the internal 1 plus x squared, we get 2x. The next step we're going to do, we can factorize the 1 plus x squared out of the terms in the numerator, and we get the following, which is then we can perform the cancellation, removing the 1 plus x squared in the numerator and 1 of it in the denominator, and then we have this answer. So this can be simplified into basically just 4x squared minus 2 over 1 plus x squared cubed. Last but not least, we find what is my f4 times prime x by differentiating f triple prime x one more time. We will same thing, apply the quotient rule of differentiation, and then we get the following. In my denominator, we have 1 plus x squared to the power 6. And then numerator, we have 1 plus x squared cubed, differentiating 4x squared minus 2, we get 8x, subtracting away, where we keep the 4 minus x squared minus 2, differentiating 1 plus x squared cubed, and we get the following: 3, 1 plus x squared, the whole thing squared, differentiating 1 plus x squared, we get 2x. And hence we can just leave it here as for now. Once we have found what is my fx, f prime x, f double prime x, f triple prime x, and f4 times prime x, I will move on to find what is my f0, f prime 0, f double prime 0, f triple prime 0, and f4 times prime 0 by substituting x equals 0 into the Foley function. So let's start with tangent inverse x. Substituting x equals to 0, we basically just have 0. right? Because tangent inverse 0 is 0. So my f0 is 0. How about f prime 0 substituting x equals to 0 into f prime x? Basically, we just have the following: 1 over 1 plus 0 is equals to 1. Hence, my f prime 0 is equals to 1. Next, we find what is my f double prime 0 substituting x equals to 0 into f double prime x. Basically, we will just get 0 because my numerator itself is 0. So anything divided by 0 is equals to 0. F triple prime 0 substituting x equals to 0 into f triple prime x. We have the following. In my numerator, basically it's negative 2. And then my denominator is just 1, so this is equals to negative 2. So hence my f triple prime 0 is equals to negative 2. How about f4 times prime 0? Substituting x equals to 0 into f4 times prime x, we get the following. Basically, it is just 0. Because my first term in the numerator is 0, my second term in the numerator is also 0. So hence my f4 times prime 0 is equals to 0. Wherefore, my f0, f prime 0, f double prime 0, f triple prime 0, and f4 times prime 0, we can apply the formula shown in the top right hand corner of this video to find the Maclaurin series of tangent inverse x up to and including the x to the power 4 terms. We have the following. My tangent inverse x can be approximated to be my f0 is 0. How about my f prime 0? My f prime 0 is 1, so we have x over 1 factorial. As for the third term, we have x squared times f double prime 0. So f double prime 0 is 0. So my third term itself is 0. The fourth term of the Maclaurin series, we have f triple prime 0 as negative 2. So we have negative 2 over 3 factorial. And last but not least, for the fifth term of the Maclaurin series, because my f4 times prime 0 is 0, so hence the fifth term itself is 0. Basically, this is equals to just x subtracting away 2x cubed over 3 factorial. So basically, it is just x1 over 3x cubed. And this is the final answer to the Maclaurin series of tangent inverse x. If you guys like this solution, help me press the thumbs up icon below this video. And do consider to subscribe to this channel for more Maclaurin series problems. I'm Bob. Thank you guys for your support and watching the video. And I will see you in the next video. Goodbye, guys.